All right, well, hello everyone, and welcome back. In this video, we're going to continue our discussion of loops and files in C++. In particular, we're going to look at how to design and debug loops, and we're going to look at some more examples of using loops and files in our C++ programs. So here's our goals for today. By the end of this video, you should have a good sense of how to do file manipulation and good coding practices in C++. We will also recognize some common loop mistakes that you should watch out for and give you some tips on how to avoid them. We'll also discuss some strategies about how you can best design, test, and debug programs which contain loops. And finally, along the way, we're going to complete some sample programs. So we have a guessing game and also a program which processes area and perimeter data using input and output files. So let's start out with a quick review. So in this bit of code here, we have some blanks that we want to try to fill in. Take a moment and pause the video if you'd like. See if you remember what code should be put in each blank. So let's go ahead and discuss together. Blank number 1 here should be include fstream. Remember, we need to include the fstream header in order to access file manipulation tools. Next, notice here we are declaring some type of value, and we notice that input file here is actually an input file stream object. So in line 2 here, we must be declaring an input file stream object. So the correct line of code is ifstream input file. Next, we move on to line 3, input file.open something. Well, here, notice we have just declared a variable named file name, which is a string. We've gotten it from the user. So here, we want to put input file.open file name inside the function open because we want to open the data file stored in file name and create that input file stream. Next is blank 4. We want to check for errors when opening that input file. So there's a few possible options for this blank. We could simply say if not input file. We could also say if input file dot fail. Basically, we want to identify whether the file failed to open. And if our file did indeed fail to open, then we display that error message and exit. Finally, in blank number 5, we're trying to read int values from our file. And notice here we are also outputting this variable number, which we have not yet assigned any value. So based on this context, we can conclude that blank 5 must be attempting to read the next number and store it inside the variable number. So the correct code that would go inside those parentheses would be while input file reads the next item and stores it in number. While input file reads the next value, stores it in number, then we output that number to the screen. So this program would actually be able to open a data file full of integer numbers, and it would display all of the numbers separated by a new line on the screen. So make sure you get comfortable with this file manipulation syntax in C++. You're going to be using this a lot. In our previous video, we also introduced some good practices, specifically about programming style. And for this course with me, you want to make sure you follow these good practices. You'll notice on assignments and exams, you are actually required to follow these good practices. And if you do not, you may lose points. So please make sure you remember to follow them. All right, and the last thing that we learned in our previous video is we learned the general steps for using a file in a C++ program. So the steps are summarized here. Remember that you want to put your data files in the same directory or the same location on your computer as your CPP file that contains your main function. You also want to remember to use the include fstream header so that you have access to all the file manipulation tools. Remember, you need to declare those input and output file stream objects using, for example, ifstream in file and ofstream out file. Remember, you need to use the open function in order to link a data file to a given input or output stream. Remember, every input or output needs its own separate stream. So if you're reading to one file and writing to another file, you will need an input stream to read from a file, and you will need a separate output stream to write to the other data file. We also covered the good practice that you want to check for file opening errors using the fail function, or you could do, for example, not in file, if that's your file stream object name. Remember, these will return true if the file failed to open, and that way you can return an error message. We also learned that we can use the input and output file stream objects in the same way that we use cin and cout. And so the input file stream object works just like cin, except it allows us to read data from a data file. And the output file stream object works a lot like cout. Remember, we can use it to output data to our files, and we can also do things like formatting, end line, tabs, new lines, and other commands. Finally, you want to make sure you use the close function to close your data files when you're finished using them. So please make sure you start getting comfortable using files in your programs. We're going to be doing this a lot, and we'll even have another example later in this video. So please do feel free to reach out if you have any questions on this. And remember, one of the best ways to get comfortable with all these tools is to sit down and code up the sample code yourself. Make sure you understand each line of what that code's doing. So with that, let's go ahead and continue on to designing and debugging loops. So let's talk a little bit more about loop statements. Remember that a loop is basically a statement or group of statements that is designed to repeat a certain number of times. And so whenever you're trying to program using a loop, you want to ask yourself these loop design questions. First question is, how many times should the loop body be iterated? Remember, the body is the stuff inside your loop. That's the statements you want to repeat. So, how many times does your code need to repeat? Maybe you don't even know for sure, so you'll have to design your loop carefully. Another question to ask is, what kind of loop should you use? Remember, we have for loops, do while loops, and while loops. Also, what should the loop body actually be? What needs to repeat? Sometimes beginner programmers can accidentally put too much stuff in their loop. Remember, the only things that really need to go in your loop body are the statements that need to be repeating themselves. So it's very important to be mindful about what it is you're putting in your loop. Does everything inside your loop have to repeat? So, general rule, the things that need to repeat are the statements that should go inside your loop. Finally, how do you control your loop? This is really important. Remember, our loop should always contain some statement or some code that will eventually cause the loop to stop. Otherwise, we'll be stuck with an infinite loop. So these last two questions are particularly important. Let's keep these in mind as we go through the rest of today's video. And next time you're coding up a loop, keep these questions in mind. Let's take a moment and briefly review the differences between while loops, do while loops, and for loops. Remember, a while loop will check the Boolean expression before the loop is even allowed to run. So a while loop might never be executed. The while loop will only run if the Boolean statement is true. And eventually you need to have some code in there that will make that Boolean statement false. A do while loop is a special case of the while loop. Remember, it checks the Boolean expression after the loop has run. So a do while loop will always be executed at least once. Do while loops are not used that commonly, but sometimes we use them for programs that require menus. You can also do a while loop to create a menu, and you just keep returning back to the menu as long as the user hasn't quit. But some students like to use do while loops to make menus. Finally, a for loop is designed to run a certain number of times. And back in our loop video, we saw the FizzBuzz interview question. And we saw how by using a for loop, we could design that loop to output the numbers 0 through 100 and increment the number by 1 each time. So a common question comes up when we start coding with loops. What should you do if you can't decide what type of loop you need? Your first recommendation is to design that loop using pseudocode. So when we say the word pseudocode, what we mean is writing in a mixture of code and English. So of course, your compiler is not going to understand pseudocode, but if you need to explain what your program is doing to yourself, to your classmates, or in a comment, pseudocode can be really helpful. You could write, for example, while the player hasn't quit, display the menu and ask for a choice. And notice this is sort of a mixture of C++ and regular English. And if you write out what you want your loop to do in pseudocode, that can make it easier to tell what kind of loop you need. As long as the player hasn't quit, display the menu, ask for a choice. It sounds like a good time to use a while loop. So while loop will keep running until the Boolean statement inside has become false. And if you translate the pseudocode into C++, you can also test out and verify which type of loop is the best fit. So usually if you do that pseudocode, write it out, and then try to write it in C++, often that will help make it clearer what kind of loop you need. So now let's go ahead and look at a few more examples. Here's some really nice loop examples. First is a common loop in video games, apps, and other programs. Very often we will include a while loop somewhere in that program, and that will keep the program running until the user chooses to quit. So there will be some variable, maybe there will be a variable called keep running, there will be something, some sort of while loop that will cause the program to keep running until we choose to quit. And notice in this case, we choose the while loop because we have no idea how many times that loop is going to run. It might run 0 times. It might run 100 times. We don't know. So the while loop gives us a lot of flexibility. Another good example of where to use a while loop is when you want to nag a user until they give you a valid input. And so you can see here, as long as x is less than 0, or as long as x is greater than 10, then we ask our user, give us an input number between 0 and 10. And until the user gives us the number we want, that while loop is going to continue running. All right, so now let's look at some common mistakes that sometimes happen when writing loops. And let's look at how we can avoid making these common mistakes. To keep things interesting, we're going to go ahead and do some more Cody sense questions. So we're going to do a series of multiple choice questions, and I encourage you to pause the video, try the question yourself, and then compare your answer to the correct answer shown. It's really good practice, and it will help you build your programming intuition. Let's go ahead and start with Cody Sense question 1. So we are told that we want to output the numbers 0 through 10. And we are asked, what will this loop output? Given some code, question is, we want to output 0 through 10, but what is this program going to give us? Take a moment and think about it. All right, well, let's just try kind of taking a closer look at this code and seeing what happens. Well, we've declared this counting variable named n, and n is initially 0, right? I'll just write the value here. And so let's keep track of what output we're going to get to the screen. So initially n is 0. So we set n to 0 again in our for loop, and we say, okay, for every n starting at 0 and less than 10, we're going to output n and then increment our counter. I output down here so we have more room. And you'll see what's going to happen here is when n is equal to 0, our loop starts, we output 0. And just the number, no new lines, no formatting. Then we increment n to 1. And we repeat our loop, output 1 to the screen. And we keep repeating. So notice n becomes 2, we output 2. Then n is incremented to 3, we output 3. And we go all the way up. Let's look at what happens when n is 9. N is 9. 9 is still less than 10, so we output 9. Then n becomes 10. But look what happens here. Our for loop only runs as long as n is less than 10. So if n equals 10, the loop is going to stop. So our outputs are only going to be from number 0 through number 9. The correct answer here is choice A. Just for fun, let's pull this up in CLion so that you can see that the output is indeed only 0 through 9. All right, so here we are in CLion, and you can see our sample program. Once again, n is equal to 0, n less than 10, n plus plus. We go ahead and run this one. Notice we only output numbers 0 through 9. How could we fix this? Well, to fix this, we need to make n run as long as we are less than or equal to 10, right? If we change our Boolean statement, then we will get our output up to and including number 10. All right, so that brings us to our common loop mistake number 1. That mistake is counting errors. So you want to be very careful here. If you are using some counting variable to control your loop, you want to make sure you know exactly where your loop is starting and where your loop is ending. And be especially careful of that Boolean expression. We want to make sure that we remember to start and stop at the correct values that our program requires. Let's go ahead and move on to our next CodeSense question. So this is a fun one. The question is asking, what will our loop output if we accidentally put a semicolon at the end of our for loop? Take a moment and think about it. Turns out the output to this program is actually just going to be the number 10. All right, so here's our program, and there is our incorrectly placed semicolon. If we run CodeSense question 2, notice we just get number 10 as our output. Program is still compiling and running, but so what you'll see is happening is, remember, if we have a semicolon after our for loop, that creates an empty loop. Remember, a semicolon acts like a period, and it indicates that our statement has ended. So essentially what we're saying here is for every n starting at 0, n is less than 10, incrementing by 1 each time, do nothing, then increment n. So essentially what's happening here is we're just starting with n equals 0, do nothing, increment n. Then n becomes 1, do nothing, increment n. N becomes 2, do nothing, increment n. All the way until n becomes 10. Once the value of n has become 10, we are finished with our loop, and we output n in the statement after. So notice, in order to fix this loop, the correct version of this code would have actually been to not have the semicolon there, and then had we run this code, we would see that we'd actually output numbers 0 through 9. But because we had that incorrectly placed semicolon, notice that actually causes us to only output the very last cout statement that happens after the loop has run. Notice clan is even giving us a warning. For loop has empty body. Clan's trying to tell us, hey, what are you doing? There's nothing inside that for loop. Might want to do something about that semicolon. So that brings us to our next common mistake, semicolons. Remember, you do not put semicolons after the initial while and for loop declaration. So you do not have a semicolon after the parentheses of the loop. Remember that semicolons act like a period at the end of a sentence. Semicolons tell C++ that our statement has ended. So if we accidentally put a semicolon right at the end of our for loop declaration, that would be the same as putting nothing or an empty statement inside our loop. That's why we saw the number 10 when our empty loop had been triggered. A little bit more about the empty statement. So basically, if you place a semicolon after nothing, we actually call that an empty statement. It will compile, but it does nothing. And so it can really help to pay attention to the warnings and information that your IDE gives you. Often you will see a warning, or your IDE will try to indent your statements for you because it's going to see that semicolon and it's going to want to do formatting around it. So make sure you use those semicolons properly. Let's move on to our next question. Here we have another for loop, and notice we are outputting our counting variable throughout our for loop, and then we have a cout statement. My loop ran n times. So my question to you is, what will happen when this code runs? Take a moment and think about it. All right, I have a question for everybody. Notice we declared n in the for statement, inside the for loop. Will n exist after the loop ends? Notice n is being outputted after the loop has finished. Will that be okay? If you're thinking something might be off, probably correct. In this case, the correct answer is choice B. This program will not compile. Let's take a look and see why that is. So here we are with our Cody Sense question 3, and notice here our variable n in our cout statement has turned a red color, and we're getting an error message. Use of undeclared identifier n. Notice n is okay in the for loop, because n was declared inside the for loop. But once our for loop has ended, n no longer exists. That is because this int variable n in our for loop is local only to the for loop. So n does not exist outside the for loop, and therefore we're getting this error. Notice if I try to run this code, it's not even going to compile. And look at the message we get. N was not declared in this scope. Remember what we said about scope? Scope is defined as the area in which a variable exists. Since we declared our variable n inside the for loop, the scope of n is only inside the for loop. If I want my variable n to exist outside the for loop, I need to declare n outside the for loop, back in my main function. Notice if I do that, if I declare n in my main function, then n will exist inside my for loop, and it will still exist after my for loop has ended. And now if we run, with that correction, we count all the way up from 0 to 9, and we state my loop ran 10 times. So notice, after outputting 9, 9 got incremented to 10, so our output from our cout statement shows that n is equal to 10 when the loop has finished. So that brings us to common mistake number 3, variable scope. So here you always want to be aware of where your variables exist. Remember, if you declare the variables in the loop, they only exist within the loop. What that means is that you can't access their value outside the loop because that is outside the scope of that variable. So if our variable does not exist outside the code where it was declared, then we will get a compiler error. All right, moving on to CodeSense question 4. We have another loop here. Now we have int n equals 10. So here we have declared n to be 10. And then we have another int n equals 1. N is less than or equal to 10, n plus plus, and we're outputting n. So this time we're being asked, what is this loop going to output? Based on our previous discussion, you can see that we've declared n outside the loop. But we've also declared a second variable n inside the loop. So inside the loop, the second n will be updated. Outside the loop, the n equals 10 value will be used. Because remember, this very first n value we declared exists outside the loop and throughout the main function. This second n only exists inside the for loop. So it's a second n variable that will only exist inside the for loop. Once we end our for loop and go back outside into main, then only the first n that we declared would be valid. So this first n is local to the main function, because it exists throughout main. And the second version of n only exists in the for loop. So that second n is local to the for loop. So looking at this code, we can therefore conclude that the correct answer will be choice A, because inside our for loop, we're going to be outputting the numbers 1 through 10. We had redeclared n inside the for loop to start with the value 1, so the value of n outside the for loop is not going to affect our for loop's output. And that's indeed what we see. A variable declared and defined. Variable declared and defined within a loop will have its variable determined by the code in the loop. So outside the loop, a variable of the same name can have a different value. So here's our Cody Sense question 4. Notice there's a little bit of a warning here. There's a comment declaration shadows a local variable. So CLion has noticed that we have redeclared the variable n. It's also warning us that our first copy of n local to main has not been used. So if we run this, we notice that only the inner n inside the for loop is actually used. All right, so the last common mistake that we want to cover for now is the increment and decrement operator. We covered this in an earlier video, but I just wanted to remind everybody about the difference between using plus plus at the end of an expression versus at the beginning. So remember, if I put the plus plus after my variable of interest, that will return the current value of the number and then increment the number after. Plus plus number, on the other hand, will increment first and then return the value of that number. So it's a small but subtle difference. So if you're debugging some code and you notice the placement of the plus plus operator, make sure that it is placed in such a way that you are not creating any sort of bugs or problems in your loop program. So let's go ahead and summarize the common mistakes that we learned. First, be careful of semicolons. Remember, you do not put a semicolon right after the parentheses of your loop unless it's a do-while loop. Next point, always be careful of the scope of your variables. Remember, scope is where variables exist, and as we learned, the scope of a variable is bounded by the curly braces where that variable was declared. So if we declare the variable in main, it exists in main. If we declare the variable inside a for loop, it will only exist in the for loop. So be careful that you don't try to access or manipulate variables outside their scope or outside the area where they exist. Also remember, if your loop counting variable is local only to the loop, the rest of the program, the rest of the code outside the loop cannot access that counting variable. So be careful there. Make sure that you properly keep track of where your variables exist. And remember, if you need to access counting variables, make sure they are not local to the loop. Make sure you declare them outside of your loop, outside of and before the loop starts. That will ensure that the variable is available both inside and after your loop has finished. And finally, be careful to use the increment and decrement operators properly. Alright, so next we'd like to cover a quick example using what's called nested loops. And so when we talk about nested loops, what we mean is that we have a loop inside another loop. So take a look at this guessing game as an example. We have a first loop up here while still playing. Notice still playing is a bool variable. So as long as still playing is true, then that while loop is going to keep running. Then there's a second while loop. Inside our first while loop, we're saying while the menu selection is not equal to 1 and menu selection is not equal to 2. Notice here, as long as we haven't chosen a 1 or a 2, we force the user to give us a valid input. If they give us a valid input, such as a 1 or a 2, then we trigger a switch statement. If they do not give us a valid input, we get the message that is not a valid choice. And notice our while loop will repeat until we get a valid answer. And look, there's even more loops inside this program. If our user chooses option 1 is play again. So here, basically, this loop keeps running as long as num tries is less than 3. So notice what's happening here is we're allowing the user 3 guesses to guess our number. If we correctly guess our number, we use what's called a break statement to end the loop. So we end the loop and update win variables if we guess correctly. And notice if we guess wrong, then we get a wrong message. So notice this program has 3 loops. A while loop, a second while loop inside the first, and a for loop inside of that. So you can imagine if you're trying to write a very complex program, you might have a lot of nested loops. And it's very important that we define and set up our Boolean statements so that these loops will properly work together and enable our program to run. So let's talk a little bit more about how do we control these loops? And how does this break statement work? So let's see how we can better control loops if we're trying to write more complex programs. So first, let's talk about ending a loop. Here are some common methods to end a loop. First method is to use a break statement. A break statement will immediately end the loop and then continue the program outside the loop's braces, where we left off. Other ways to end a loop, well, you could run a specified number of times. For example, with a for loop. If we know how many times we need to run, we just tell our counting variable to stop our loop once we've reached the maximum number of times. Another way to end a loop is to ask before iterating. Ask the user, do you want to play again? Another approach is to end the list with a sentinel value. This is a little bit more of a approach that beginner programmers use. Generally, it's better to have a cleaner approach in case your user accidentally doesn't use a sentinel value properly. But you could use a particular value to signal the end of the list. So that is one approach that is sometimes used in order to stop a loop. You could say, enter your numbers, then enter a negative number to stop. And then the last approach, which we saw when we worked with files, was to use the file extraction operator and the input file stream objects. So remember, if we use our input file stream object to read data in our file, that statement will return true as long as some item was read to next item. So as long as something was read from the file, then we return true. So this is a really effective way to keep running your loop, keep reading your data file until the file is empty. Once you've reached the end of the data file, your loop will stop. Let's go ahead and look at a few examples of each of these practices. First is a break statement. So here we have some code, and you can see we are going through and we're asking our user, enter 10 negative numbers. And so here we go ahead and we update our counting variable. We take in a number, and then look what happens if the user enters a positive value. So if our user entered a positive number, if we entered a positive number, remember we're not supposed to do that, we wanted negative numbers. If we were given a positive number by mistake, we're going to get an error message, and then a break statement will trigger. Break statement will end the loop. Oops, and this should have been indented here. Remember, this sum statement should be indented since it's still inside those outer braces. But we see this break statement would end the loop, and notice the sum would not trigger. The sum would not trigger if we had a positive number, and so this sum would only include the loop iterations before our break statement. So the break statement would end the loop and continue at the next point outside the loop. So we completely exit the loop in which the break was triggered, and we move to the nearest statement outside. Let's do a quick practice question here. So once again, we have some sample code, and here we want to enter a choice. We have a while loop, and notice inside our while loop, we have an if statement. If we were given a certain value for our choice, then we break. Question is, after this break statement runs, what statement triggers next? So remember, we're going to exit the loop. And so in this case, everything inside here is still in the loop. So we will actually exit the loop entirely and continue at the statement outside the loop's braces. So in this case, our correct answer would be done. Remember, in this case, the else statement will not trigger because the if statement had triggered. And so nothing else is inside of our loop. And so we immediately move outside our loop and see out done triggers. So let's briefly summarize. We just learned that the break statement can be used to exit a loop before normal termination. So this allows us to end a loop early, often in cases where we detected errors or met other special conditions. One other thing to be careful of is break will only exit the loop in which that break statement occurred. So if you need to exit multiple loops, you may need multiple break statements. Finally, remember that after that break statement, the program is going to execute the current block. So that's basically the current set of braces. We continue after the braces have ended. So we basically go to the next section of the program outside those braces, and we continue with our program. So that's it for break statements. Let's look at our next way of controlling our programs and loops. Another way to control our loops is to stop after a predetermined number of runs. So a good example of this is our FizzBuzz program. We know that we only want to output numbers 1 through 100. So in this case, we can automatically stop once we have outputted all the desired numbers. And so for loops are really good at this because it's built into a for loop. For loop is guaranteed to only run a predetermined number of times based on whatever you have put inside the for statement. Next one, ask before iterating. So a do-while loop is used to illustrate here. You'll remember this example from an earlier video where we first output a greeting, hello, and then we ask the user, do we want another greeting? And here we keep running as long as the user says yes. There may be cases when you need to write a program like this, where if the user wants to go again, then you keep running. If the user says stop, then you stop. Next one, ending with a sentinel value. So here, We see an example in this guessing game. So in this particular case, the sentinel value is the number we're trying to guess. And so our loop will actually keep going until the secret number is guessed. You could also do something where once you are finished entering data, you end with a certain value. One thing to be careful of is that if the sentinel value is detected, then the rest of the loop will not run because the Boolean statement becomes false. So that sentinel value will be read, but the loop will not execute its statements when the sentinel value is detected. And finally, our last approach for working with loops and controlling our loops is to use running out of input. So the while loop is typically used to detect when we have run out of input data from a file. So this input file number, this will return true as long as something is read from the input file. So once we have read all of the data, our while loop will become false, and then our while loop will end. So that's an extremely useful way to keep reading from our data file and keep repeating our loop until all the values have been read. All right, so what we'll do is we'll talk a little bit more about testing and debugging loops, and then we'll end with one more demo that is often similar to common questions I like to ask in assignments and exams. So let's talk a little bit about testing loops. And so it's an extremely good practice, both when you're writing an algorithm and when you're actually running your code, is you always want to test your loop under certain conditions. Here are some of the times when you want to check your loop. You want to give your loop input so that you trigger 0 iterations of the loop, 1 iteration, 1 less than the maximum, and finally the maximum number of iterations. This makes sure that your loop runs under the full range of test conditions. You want to ensure the loop can handle the full range of possible inputs. And you want to make sure there aren't any unexpected errors. For example, if you're programming a guessing game, you want to make sure that if somebody guesses the number correctly on the first try, that you get the appropriate response. You would not want to automatically ask the user to guess again if they happened to guess right the first time. So you want to make sure that you can handle all the different types of iterations that the loop may need to do. So every time you make a change that is significant, you should double check and make sure any changes you made did not affect your loop's behavior under these given conditions. Let's also talk a little bit about debugging loops. Here we have the most common types of errors we see when working with loops. The first kind of error is called an off by one error. This is when our loop runs one too many times or one too few times. Basically, we're off by one iteration. If you see an off by one error, I want to double check if you have any Boolean comparisons. maybe you missed a less than or a less than or equal to. Check that you initialized your loop to start at the correct value. Are you properly initializing your counting variables and any other variables in that loop? Also, make sure your loop can handle the case where it doesn't run at all or has 0 iterations. Another common loop error is infinite loops. And typically these happen if we don't set up our Boolean expressions correctly. So you want to make sure, often best to test for greater than less than instead of equality. And remember that double variables can actually contain some error due to rounding. For example, if I set a double variable value to 5, that value is going to be stored as 5.000, but then there's going to be some error digits at the end of the double. So if you're testing for equality and using a double, you might accidentally return false because of those error digits. Watch out for error in your double variables. Another common loop error is assuming that your error is inside the loop, but it's actually elsewhere. Maybe you forgot to initialize your variables. Maybe you're missing some additional controlling values to help your loop. Or maybe your error really is somewhere else. So definitely use the debugger and our variable tracking tools to help keep an eye on what's happening in your loops. And remember, you're always welcome to reach out and ask questions for help as well. Let's go ahead and end with one more demo or example that sums up all the skills we've learned so far. So in this example, we have a data file, and we're told that our data file contains different shape names and dimensions. So we could have a square, a circle, or a rectangle, and then we're given a dimension. So this would be like the length of the square edge, or we would have, for example, this would be the diameter of our circle, or the length and the width of the rectangle. So this program is a little tricky because, yes, we want to open the file, read the data, and find our shape area, but depending on the type of the shape, we may need to do the calculation differently, and we may have a different number of inputs that need to be read from the file. We also want to output the data to a second file. The second output. So there's quite a bit going on in this program. Before we code this up from scratch, let's just briefly talk through what this program needs to do. So how would you approach this? Well, we need to open the file, read the data, and find the shape area. Let's assume that we have done everything correctly to open the file. Let's suppose we have just opened our file and we have the word square. Well, we would need to read the shape type from the file. And then we need to check what type of shape we have. If we have a square, we read one length value from the file, and we calculate area as length times length. If we have a circle, we read one diameter value from the file, and then calculate area as pi, or 3.14, times diameter divided by 2, or diameter divided by 2 squared. In this case, since we can't do squared, we'd probably just do diameter divided by 2 like this, or you could use the power function. And then finally, if we have a rectangle, notice that we have to read 2 values from the file. So notice there are 2 more values we would need to read, a length and a width. And then area would be length times width. So basically, we need to read each value from the file. Basically, read each shape from the file, and then do these statements. And then finally, of course, once we have read the shape from the file, we need to output the shape type, the area, to the output file. So all these statements need to repeat from each line of the input file. First thing we read is shape type. Then, depending on shape type, we read either 1 or 2 additional values. Then we calculate area and output all the data to an output file. Let's go ahead and try coding this up in CLion. And you'll see that this is a really great practice for ensuring you know how to use loops, if statements, and file manipulation. So I highly recommend you go back through this program and try it yourself. All right, so here we are inside a blank CLion program. So let's just go ahead and code this up from scratch. So we definitely need our include IOStream header. We also need include fstream, because we're going to be working with files. And I'm going to also include the string header, just in case, since we're working with strings. And I also want to use the standard namespace. Then we create our main function, and we will put all our code inside. First, we need to declare some variables for the program. So what do we need? Well, we need some strings to hold the input file name. I'm going to go ahead and write it like this so it's easier to read. So these are variables to hold the name of input and output files. And then Notice what else I might need. I'm going to need a string variable to hold the shape type. This will hold the type of shape read from the file. I'm also going to need some double variables. Remember, it's possible that the data in my data file could be an int, but just in case I have some decimals, I'm going to use double so that I can accommodate decimals. I'm going to declare a double length, height, and radius. And so these will hold the dimensions of the shape read from the file. I'm also going to declare a double variable called shape area that will store the area calculated for a shape. Okay, so there's our variables. That should be what we need to get going. Now we need to declare our input and output file stream objects. So in this case, I'm going to go ahead and declare input file as my input file stream object. And my output file stream object I'll call output file. Remember, you can name them whatever you want, but you want to make sure you know which one is which. Now we need to ask the user for the name of the input file to read. So this is the input file where the shape data is stored. So in this case, we do have this input file called shapes.txt. And you see that there are squares, circles, rectangles, and triangles inside shapes.txt. So in this case, we don't know for sure that the user is going to give us that file, so let's just do a cout statement. Enter the name of the data file to process. And then we can say cin. Remember, we're going to ask the user for a file name, or we're going to enter and save that file name to input file name. We also need to ask the user for the name of the output file to write the area data to. So we ask the user enter the name of the data file where area data should be written. And then we read that keyboard input as output file name. Next approach is to check for errors when opening the file. So again, we really only need to check for errors opening the input file because that's the one we're reading from. Output file should be automatically created if it does not exist. So we can say if input file.fail, if we fail to read that input file, then we can output a message, could not read the input file. And then we could exit. And this would end the program with error code 0. What did I forget? Remember, before we check for errors when opening the file, let's make sure we actually attempt to open that file, right? So input file.open, here we want to open the file stored in string input file name. And of course, we want to make sure we open our output file. So we use our output file stream object to open output file name. So here we're using open function, open input file and output file. Notice the input file is opened using the input file stream object. Output file is opened using the output file stream object. So you need to make sure you keep output file stream object associated only with output, input file stream object associated with the input file. So now that the file has been opened, we can read the data from the input file. And of course, first, we must read the shape name. Then, depending on the type of the shape, we use if statements to read more data and calculate area. So in this case, we have the string variable shape type that we declared. So what we can do is we can use a while loop and say, well, input file, while input file reads the next thing to shape type. So here we are reading shape type from the file and storing in shape type. So now we have read, we go to shapes.txt, we have just read the very first item from our file. We need to check which kind of shape we have. We could be a square, circle, rectangle, or triangle. So we need to have some if statements to capture each different type of shape. So we can have if shape type is square, all right, so if our shape type is square, then notice we're going to have to read one more data value from the file, and then we calculate our area as that length value squared. So in this case, we will say in file, we're going to read this. So we read the length value from the file, and then we can say shape area equals length times length. And then notice, once we have calculated our shape area, then we can also go to output file. And here we can say output our shape type. And notice we can separate our data by tabs to make it look a little nicer. And then the area. So see, what we're essentially doing here is if our shape type is a square, then we know we need to read one more data value from that line of the file to get our length. And we calculate area as length times length. Then we can go to our output file and send our shape type, which is square, and our shape area, which is length times length, to that data file. Remember, we also have to check the cases when we have different kinds of shapes. So what if we have circle? Or what if we have rectangle. Right? So we need to make sure we update our code for each of these cases. So here, the shape type is triangle. So we have to capture what we do in each case. So the circle case is actually going to be very similar to the square case because we're going to read one more data value from the file. So if we have a circle, we just read our diameter from the file. So here, instead of saying input file read length, we will say input file read diameter. Because oops, and I think I had accidentally given myself radius instead of diameter. I wanted to declare a variable named diameter here. So in this case, we read diameter from the data file, because that is the only other value I'm given for circle. And then I can say my shape area will be 3.14 times diameter times diameter times 0.25, right? Because it's basically pi times radius squared divided by 4. Then notice if my shape type was a circle, then my output will be written as circle and the circle's area. Next, we consider the case if our shape type is a rectangle. Notice if our shape type is a rectangle, then we're going to have 2 more values to read from that file. So therefore, we have to read 2 more things. Here we would have to read a length and a width. Oops, or in this case, I think I called it a length and a height. So notice, make sure we use consistent naming. So I'm going to read 2 data values from the file. So in this case, I need to read my length and height from my file, and my shape area for a rectangle is going to be length times height. And lastly, triangle is a little bit similar to rectangle in that we need to read the length and the height, but then the area will be half times our base times our height because it's a triangle in that case. So notice I've designed this while loop very cleverly so that I first check what kind of shape I have, and depending on my shape, I will do different actions to ensure that I have read the data from the file correctly and to ensure I've calculated my area correctly. And once I have done that for the individual shape type, I output that shape's data to my output file before moving to the next item. That way I make sure my data is outputted to the output file before it could possibly get overwritten by the next line from the file. And then we can go ahead and say data has been written to output file name. And then, of course, we want to make sure we say input file name dot close or input file dot close and output file dot close to close our data files. So there you have it. That concludes most of what we need for this program. The one other thing we could consider doing if we want to make our output file look a little nicer is we could If we wanted to have like a header, we could also have some code at the beginning, right before our while loop, and we could say output file shape type, and then shape area. And then that way, when we output our data to the file, we will have those headings there. So let's go ahead and run this program using shapes.txt. And let's see if we can correctly process this data and determine the area for all of our shapes. Go ahead and run our program, and oops, it looks like I forgot a semicolon somewhere. So let's go ahead and fix that. It looks like I just forgot a semicolon right at the end. And yes, indeed, data has been written to output file name. Oh, I forgot that operator, but everything else looks correct. So go ahead and run it again. And here we go. So enter the name of the data file to process. I want to process shapes.txt. And let's just call it output area data.txt. So I just made up that name just now. Now let's see what happened. If I open output area data.txt, what am I going to get? See if I can find that file. There it is, output area data. And hey, would you look at that? I was able to correctly output the data to my file. So I have my shape type, square, and notice if I compare to shapes.txt, my square with a length of 5, that square became a square with an area of 25. Circle with a diameter of 10 became a circle with an area of 78.5. Rectangle with length 2 and height 3 became a rectangle with area of 6. Triangle with base 4, height 6 became a triangle with area 12. So as you can see, we were able to successfully process all of the data up to and including our very last shape, which was our circle. So I highly encourage that you try going back through this example and see if you can code this up yourself from scratch. This is a really great practice to verify that you understand how to use loops and data files effectively. All right, so this concludes our video for today. So I hope you found these examples helpful as a review of file manipulation and good coding practices. Please keep an eye out for those common loop mistakes and do your best to avoid making them. And definitely keep those strategies we covered in mind as you design, test, and debug your programs with loops. And finally, I highly recommend that you go back through those sample programs, including the guessing game and our area data, and make sure you understand how to manipulate those programs. You're probably going to need to do something very similar on assignments and even on exams. So thanks everyone for joining the fun, and we will see you all in the next video.